Today will be the second part of inequality word problems. Today we're going to focus on not only interpreting the phrasing, but also being able to build an inequality, solve it, and then interpret the solution to satisfy the word problem itself. So I have a practice page here with 4 problems that we'll try together. Number 1 is a pretty bland example, but just to get us started, first question says, if 5 times a number is increased by 4, the result is at least 19. Find the least possible number that satisfies these conditions. So to start, I always like to write out what my variable is going to equal in words. So in this case, they want us to find the least possible number. So X is going to represent the number that we're looking for. So as we reread through this, anytime they mention the number, we can think of that as X. So if 5 times a number is increased by 4, how could we write that algebraically? So 5 times a number, I'm thinking 5X. And if we want increased by 4, that's telling me we want to add on 4. Next, it says the result is at least 19. So if you recall from Friday, at least is the greater than or equal to, because we want 19 or more. So at least 19. All right, and you already know how to solve the inequalities, so go ahead and pause the video if you want and do that. If not, I'll write the steps here quickly. And what you should have seen is that X is greater than or equal to 3. So if I want to write a phrase or a sentence to answer their question here, find the least possible number that satisfies these conditions, I would say the least possible number is 3. So 3, 4, 3.75, since they didn't tell us what type, but anything 3 or higher would work for example 1. All right, looking now at example 2. The cost of a gallon of orange juice is $3.50. What is the maximum number of containers you can buy for $15? So again, first and foremost, we want to start with a variable, and you can use whatever variables you want. I always like to use X because that's traditional, but you can change it out. Maybe you call it C for containers, your total choice. In this case, they're asking us for the maximum number of containers. So I'm going to say X is number of containers. And if you want of orange juice. And we don't have a lot of information here. It just says the cost of a gallon of orange juice is $3.50, and we have $15 that we can use to spend on those containers. So if you think about it, when you go to the grocery store, if they're $3.50, we take $3.50 times the number of containers that we buy, and that'll tell us the total price. If we want to know the maximum number, well, if I have $15 in my pocket, can I spend more or less than $15 on orange juice? Hopefully you were thinking less than. The second question is, can we spend exactly $15 or strictly less than? And if I have $15, I could spend all of it, but I can't spend more than that. So we'll simply say 350x is less than or equal to 15. And then to solve it, we'll just divide. And this brings us to our first point with word problems that we're going to run into. When I do the division, maybe you did this and we're a little concerned, I don't get a whole number. I'm getting about 4.29. So what does that mean? Well, because when you go to the grocery store, you can't buy 0.29 containers of orange juice, what that's telling us is that when we phrase this, we're going to use a whole number to represent the number of containers, because that's how we purchase orange juice. So I would say the maximum number of containers I can buy is, and how many would that be? Well, 4.29 we have to do less than or equal to. So the closest integer within that boundary is 4. So we can buy 4, 3, 2, 1, or we don't have to buy any at all. But 4 is the highest number without going over our budget. Example 3. So Jason is saving up to buy a digital camera that costs $490. So far, he's saved $175 and he is able to save $45 per week. How many weeks must Jason save in order to afford the camera? So they gave us the phrase, how many weeks? That's what we're looking for. So I'm going to define my variable as number of weeks. And that's helpful because when I go back to answer the question at the end, that's going to be super easy and quick for me to look back at that variable definition and say, hey, that's what I was trying to find, and formulate my sentence. Now, we have a little bit more information on this one. We have a camera that costs $490. We know he saved $175 and he is able to save $45 per week. So let's start with the things pertaining to X. I noticed that when I underlined $45, that was a per week amount. So I'm going to write 45X because every week he's saving $45. Now, it also says he's already saved $175. So in addition to the $45 he's going to save per week, he already has that $175. So we'll add that on to what he's saving weekly. Now, the cost of the camera, however, is $490. So does his money, his savings, need to be more or less than $490 for him to be able to afford the camera? They didn't really give us a phrasing here, so we have to think about what this scenario is telling us. So do we need more than $490 or less than $490 to be able to buy it? Hopefully you were thinking more than $490. The second question always is, do we need exact, or is it strictly greater than or less than? And in this case, if he has exactly $490, can he buy the camera? Sure. So we can attach the equal to on there as well. Now we can go ahead and solve. So we'll subtract over the 175. And we get 45x is still greater than or equal to 315. And then when we divide by 45 on both sides, we find that x is greater than or equal to 7. So what does that tell us? We'll go back over here to our variable. X is the number of weeks. Well, that means the number of weeks is greater than or equal to 7. So Jason needs to save. And you can use whatever phrasing you want. I'm going to say needs to save for at least 7 weeks. You could say he needs to save for a minimum of 7 weeks. You could use the inequality and say greater than or equal to 7 weeks, whatever feels comfortable for you. But we do need to get that inequality phrase in as well as the number that we found as our solution. All right, last one, and then you're going to get to do some practice on your own. So Adrienne works in New York City and makes $42 per hour. She works in an office and must get her suit dry cleaned every day for $75. If she wants to make more than $260 a day, how many hours must she work? So first and foremost, what are we looking for? X is going to be the number of hours. Now, the second thing I want to do is underline some key phrases here and numbers that we're going to need for inequality. So she makes $42 per hour. She gets her suit dry cleaned every day for $75, and she wants to make more than $260. I'm going to start with the more than $260. Her money that we're going to fill in on this side, her money that she makes needs to be more than $260 every day. So more than, that's another phrase for greater than. So her money over here that we're going to write needs to be greater than 260. So let's go back and look at the 42 and the 75 because that's money that she's either bringing in or taking out. So at first glance, it might be kind of logical for you to just write 42x plus 75. Well, let's think about this for a second. If I do 42x plus 75, what does that really mean? Well, that means she's making $42 per hour, so that's $42 into her pocket every hour. If I add on 75, that means that when she goes to get her suit dry cleaned, they're actually paying her an additional $75 every day. Does that seem logical to you? It shouldn't. So actually, contrary to sometimes popular belief, we actually have to subtract the 75 because 75 is a deduction of her daily income that she has to take care of every day. So now that we have our inequality set up, we're going to first start by adding over the 75, and that'll give us 335. Now we'll go ahead and divide by 42 on both sides, and again, we're left with a decimal. So I'm getting 7.98. And what that means here is it all depends on how she's paid. If she's paid an hourly rate that's on the hour or on the quarter of an hour, it all depends. In this case, since we're looking at x is greater than 7.98, I would probably just say Adrian needs to work and again, I could use that same phrase, at least, I'm going to go 8 hours because we're super close to 8 anyway at 7.98, and that is higher than 7.98. What I don't want to say is at least 7.98 because if there's no equal to here, so if she works exactly 7.98 hours, she's not going to make the cutoff. She's going to be at exactly $260 on the day. So at this point, you're going to try an IXL that's going to practice just some very simple setup, get you practicing working with the inequality symbols and do a little bit with the variable and an additional value. And then there's also an inequality word problem practice that's going to post for you to practice and then be able to check your answers. If you need anything, feel free to reach out and good luck.